Hello guys, so today we're talking about the trigonometric integrals that appear in this chapter, okay? So let's move into the first part. So here we have the very formula exam type problems like the integration sine x power of n and from 0 to pi over t, okay? So as before we said, sine 3x can be written as 3 sine x minus 4 sine x cubed, right? But then we can written that as sine x cubed equals to 3 sine x minus 3 sine 3x over 4, okay? That is for these equations. So that for this integration, you can just written down as the second method, and then you can just written down into this form, okay? Because the sine 3 sine x, the integration is negative 3 sine cosine x, and for sine 3x, the integration is for 1 cube cosine 3x, okay? And divided by 4 from 0 to pi over 2, okay? So we have to understanding for how to transform the trigonometry forms, like how to transform the sine x cubed into different sine x and sine 3x, okay? And also here's a very quick practice for you. So let's maybe do this problem together, okay? So first we have sine cube x equals to 3 sine x minus sine 3x over 4, okay? So then we can just use input into the first equation, and then we can set equals to integration from 0 to pi over 2. And here is for 3 sine x minus sine 3x over 4 dx, okay? So after integration, you can set the answer here is for negative 3 cosine x, okay? Negative 3 cosine x. And here is for plus cos 1 over 3 cosine 3x. And here is for, yeah, here's for divided by 4. And from 0 to pi over 2, okay? So you can just put the values into it. So here we can say that it's negative 3 cosine pi over 2, and then plus 1 over 3 cosine 3 times pi over 2, okay? That is for this equation. And divided by 4, and then finally put 0 into it. So it's minus, here's for negative 3, and here's for plus 1 cube, 1 over 3 over 4, okay? That is the answers in question 1, okay? And for question 2, you can set here is for integration from 0 to pi over 2, that is for cosine x squared, okay? So here you can first just transform cosine x squared into cosine x, okay? Because we knew that for cosine x squared equals to the, maybe for cosine 2x, it equals to 2 cosine x squared minus 1, right? So we can set cosine x squared equals to cosine 2x plus 1 over 2, okay? So that's this equation, we can just written down like integration from 0 to pi over 2 cosine 2x plus 1 over 2 dx, okay? That can be written down as a half and times a half sine 2x and plus x from 0 to pi over 2, okay? Then you can put into it. So that is for a half. And pi over 2 into it, that is for a half sine pi is 0 and plus pi over 2 and then minus 0, right? So value here is for pi over 4. And for last problem, you want to show that sine x squared equals to cosine x squared. So you can just transfer them into the cosine 2x. Because we knew that cosine 2x equals to 1 minus 2 sine x squared. And also it equals to 2 cosine x squared minus 1, okay? But then you can put cosine x squared and sine x squared into it. So for sine x squared, we can set it equals to 1 minus cosine 2x over 2, okay? And for cosine x squared equals to cosine 2x plus 1 over 2, okay? But then put into this equation and you can try to simplify it and you can find the final answer that they're equal to each other, okay? That's for this our lesson. So I hope you can truly understanding for how to use trigonometries in the integration problems. Just try to simplify them in formulas, and then you can just solve for all the problems. Okay. So see you next time. Bye.